Welcome to Spring LIB.
Okay, we are given an equilibrium expression. We're told that 2SO2 gas plus O2 gas is in equilibrium with 2SO3 gas. Okay, and we're told that delta H is less than 0. Right? What does that mean? That means that heat is a product. Heat is released when this reaction proceeds in the forward direction. That's what having a negative enthalpy means. We release heat. Okay, so we may consider heat a product of this reaction. Now, I will note that in the upload for this question, it says, how will each of the following changes affect an equilibrium expression? Whatever those changes didn't get copied, right? So I don't know what changes we're supposed to be considering. All I know is that there are some changes that may. So I'll just propose some, and hopefully that'll line up with what your question is. You can always re-upload the question and just make sure to include what those changes were. So usually when I see these problems, they'll be like, what happens if we cool it down, right? Cool it down, or lower the temperature, okay? And then we have to remember, okay, if we're lowering the temperature, that's like removing a product, right? So if we lower the temperature to reestablish equilibrium, the equation is going to want to return the temperature that we took out, meaning it's going to want to generate heat so that the temperature goes back to what it would be, right? So if we cool it down or lower the temperature, right, then we are going to push the reaction forward, okay? What if we heat it? What if we heat the reaction? RXN means reaction. Well, it'll have the opposite effect, right? Heat is a product of this reaction. And if we heat the reaction, if we warm the reaction, I should say, if we warm the reaction or raise the temperature, right, we're going to be butting up against this heat, right? We're going to be adding product. And if we add product, it's going to want to push backwards to remove the excess product, right? Anytime we add something to one side, it wants to counteract it. So if we added a bunch of oxygen, it would push forward to remove that oxygen because oxygen is consumed going left to right. So let's actually consider this. What if we add helium? Okay, we're just going to pump in gas, which is the same as increase the pressure. Okay, same effect. Adding an inert gas that won't affect the reaction or increasing the pressure. Well, consider that under the assumptions of ideal gases, that we have 2 molecules of gas here, 1 molecule of gas here, and 2 molecules of gas here, meaning that in total, the left-hand side has 3 molecules of gas, while the right-hand side only has 2, right? So we can kind of think of going from left to right, the effect is reducing pressure, or going from right to left, we're increasing pressure. So we could say like plus pressure, right? Pressure increases, right? Okay, so if we increase the pressure, the reaction is going to want to counteract that and decrease the pressure, right? If we go left to right, pressure goes down. Okay, so if we increase the pressure, it's going to want to push to the right. So this would push forward. Okay, what if we decrease the pressure? Well, we get the opposite. Right? If we decrease the pressure, the reaction will want to counteract that and increase the pressure, which it can do by moving backwards. Right? So if we increase the pressure, the reaction will push backwards. Okay, and those are the types of questions that are usually asked. Hopefully that matches with what your questions were asked. Otherwise, re-upload and someone can answer the question again.